Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Welcome, everyone, to Happy Path Programming. I'm James. I guess we said that in the intro. We don't need to say it again.
No,
but today we have with us Julie, who we've known for many years.
Julie.
Just Julie.
No last name needed. Too confusing.
What is your last name now?
Julie Amundson. That's my name.
Amundson. Awesome. Yeah, it's funny, we see each other in person, and I really don't know most people's last names. It's just first names.
Welcome
I guess
to
it's good
my
to be on a
world.
first name basis. So.
Well, I guess I can tell you worse than that. I've been virtual, working for a year, and people are starting to come back to the office. And I saw some people that I had video calls with, and I was used to reading the boxes, and I'm like, I don't remember which one you are. So it's pretty bad.
It's going to be an adjustment going back to non digital life, where it is nice to have people's names at the bottom of the screen and or bottom of their video.
Now, if your Google Glass did that, I would totally have those. I could come across as the friendliest person in the world if I knew everybody's name.
Oh, hi, Bob. Great to see you.
How are the wife and two kids? One of them just had a birthday, didn't they?
Data screen on your glasses.
Yeah, that's right. Just read it off. Although they say that Google Maps is making us stupider. And now Julie just told us that Zoom made us stupider.
Yeah, it did.
It's just co-evolution.
Yeah. There you go. That way to put a positive spin on it.
So, Julie, it's great to have you. And so you were beginning to tell us about what you were researching when Bruce and I saw you in person many years ago out in the Bay Area. So what was that again?
It's called a framework called active inference. And I think folks who are familiar with reinforcement learning, you could probably draw an analogy where you have this agent that has some sensors, and it is kind of actively exploring its environment and really trying to learn the structure of the world and the dynamics of the world, kind of like a baby would. And then it kind of sort of builds up its own network and starts to seek reward, like, hey, I don't want to be cold right now, or I'm hungry. And so there's a huge body of research by Carl Friston and a number of others that we were following, and really wanted to implement this as a practical, real world agent that we could put into perhaps embodied cognition like a robot or something. And good progress made on a demo, but unfortunately the second round of funding did not come in, so it's temporarily shelved right now.
So are you telling me that those guys who did the juice in a bag with the weird blender, they could get a whole bunch of money, but your AI research couldn't?
Yeah, the spend $400 so you could squeeze the juice. Well, I mean, I'll say between 2015 and 2017, there was kind of a shift in terms of the bar you had to meet to get funding. I think our problem was we needed a few years to really dig down into the research, and VCs want to see a business model right away. So, maybe we could have, tried to figure out how to collaborate more with universities or get some kind of grant. That would probably have been a good route to go.
Mm-hmm. So you had started, this was a startup that you and a partner were doing.
Yes.
Right. And how long did you go before you decided to start down?
Until my own bootstrap angel funding started to run out. So we started in, 2014. And then by late 2017, I was like, I don't think I can fund this anymore, like self-fund this anymore. So
that's a bummer. It does seem like the neural networks are kind of been the craze for a while, but they don't really, like, they're not actual cognizant things. Like, they don't actually learn. They don't learn from their environment. They don't imagine.
No.
And so they're missing a whole part of what human cognition is all about, right?
Yes. And this is really the difference between what I was working on and machine learning, right? Machine learned models are really attempting to, build a model of some like high dimensional, space, where the real or actual like shape of it is not known, and it can only be inferred by looking at a bunch of examples, trying to pinpoint. The problem there is that the shape of the world changes, right? There's dynamics. So, like, once you learn, from a given data set, next week the data set might actually shift. So, we kind of fake that a little bit.
Because
In
it's just a
many
model. All it is a model, right?
it's a
Like,
model. And I guess maybe, from a software engineering perspective, like the analogy I love is to give is that it's basically like you write code that writes other code given some data, right? And so
yeah,
if you think about how hard it is to test the software system where you directly wrote the code that's performing some action in production,
we're
this
not
is
even
like
good at doing that. So,
adding another level of indirection as well as this kind of, this data set that has to come from somewhere. So
huh?
it's that's why it's so hard.
Yeah.
I learned so much about science by that one WTF where we had the hack. The theme was machine learning, and James mostly did the work. But anyway, we just
I
did some.
did.
Yeah, I think so. We just did some kind of coin toss thing. Didn't
Huh.
work very well, but my understanding over the next few years of what science was, because I, I had studied physics as an undergraduate, and I had gotten really stuck, in particular when the professor would write an equation and then he would start throwing away higher order terms. And I'm going, the equal sign says it's an equation. You can't be throwing away parts of an equation. I had no understanding that his initial equation was just guesses at how the world would work, and then they say, oh, does it fit, do these terms make it, now I totally get that, but I
Huh.
had to have that experience with the machine learning exercise before it really started to make sense. And
Because they're
now,
both just trying to create models
exactly,
that appear right.
that appear right, and the limitations of the human are that, well, I got to be able to fit these in my head. I have to be able to make sense of these pieces in my head. The machine learning thing is like, no, it doesn't care. All it has to do is go, does it fit the data, and ideally, is it predictive? And that's true with both of those models. And of course, with the machine learning data, as Julie says, well, the data that you have doesn't necessarily show changes. So is that what you were working on, was how to incorporate the changes in the environment?
Yeah. So, I mean, I guess a typical mainstream machine learning model, like a neural network or even like a simple linear model, really just has this training data set. It just has a whole bunch of inputs and then a label, and the label is what's the right answer. And from that data set, the model needs to kind of infer what correct answers would be given some other, inputs. And so, the problem is, like, I mean, we could take an example around, let's say, Netflix streaming. Like, if you're trying to predict, hey, do we think that somebody's going to enjoy a particular movie? Well, things can change over time. The catalog of available titles can change over time. The seasonality can change. Like, you don't want to recommend a Christmas movie in July. Different patterns and tastes around the world. So just sort of saying, oh, we did it once and now this is the correct answer for all time, isn't actually going to work.
Right, and my mood could change. And you don't necessarily track that, even though I might start watching particular kinds of things. Your algorithm might not catch that and say,
Right,
"Oh, he's looking for comedies now." So I mean, it seems to,
right.
but I don't think it takes into it.
Models are static, and we create them, and then we have to then recreate them and see like, okay, do these fit? But it sounds like what you were working on was a more dynamic learning.
Yes. And so what I was working on before would actually continuously, like actually on a certain sort of cadence or time step, let's say every 10 milliseconds, take a sample, right? Maybe it has, like a heat sensor or a light sensor, and it's continually taking a sample. And there are some machine learning models that try to model sort of sequences over time, but they don't always do it in a continuous fashion. So there's these sort of things called LSTM, long-term, short-term memory. It's been a while since I studied them, so don't ask me to explain them. But so there are certain machine learning models that take into account sequences, but what I was working on would continuously sample and update its representation of the possible transitions and the possible sequences, like, I need to walk down the hall to get to the fridge, and then it would be able to respond to, hey, the fridge actually moved, to a different location, and I need to update my policy to go to this other location, right? So those are some examples.
And that doesn't even take into account things like, well, your sample rate might be limited by your machine capacity, but if you don't sample fast enough, you can lose valuable data. Like, imagine you had a village and you were getting data from that village, and you sampled once a day, and then you get it when the sun is right overhead or something like
Right.
that. And so it would seem like that's a constant factor when actually it
Exactly.
isn't.
So that does matter, and so you do need that sample rate to kind of match, to be able to observe the changes in the world.
Mm-hmm.
Yeah.
That's cool.
So what you're saying is it's a really hard problem.
It is. Not fully solved, but I think that progress is being made. It's been a little while since I paid attention to the updates in that space, but I'm sure I'll come back to it someday.
Seems like most of the energy is still kind of neural network
Yes.
development.
Yes. A lot of neural network. I think now it's kind of this renaissance of, this problem that we solved, maybe with logistic regression in the past, could we improve on it with a neural network? So like in terms of the technology stack, like we really are seeing this flourishing of the Python ecosystem. So like the news of the day is really TensorFlow and PyTorch as like dominating frameworks, for doing neural networks.
Yeah.
One of the tensions or the challenges at Netflix is like Netflix has many years of practice at operating the service at scale on Java, the JVM, and at the same time, the machine learning libraries are really being built up in Python.
Yeah.
And so we're doing a lot of investment on like, how do we, for example, do sort of the upstream data pipelines to get the data to the model in the JVM. And actually Scala is popular because of Spark. And then downstream of that, apply Python to so that we can take advantage of, TensorFlow and PyTorch.
Yeah.
And all the people who've learned machine learning, and that's the language they know.
Yeah.
Yes. Yeah. And actually, I'll say there's two, and this kind of, Bruce, I think this gets into one of your topics that you're interested in, which is organizations.
Mm-hmm.
There's really kind of, two main types of machine learning practitioners at Netflix. One is actually called algorithm engineers. And these folks are software engineers who are also ML experts. So they kind of span the spectrum of, kind of the research of new ideas, perhaps even new, sort of modeling techniques, all the way to, hey, this model needs to run, and if it doesn't run, then either the Netflix page won't get shown, or maybe a degraded experience will be shown. So they're kind of in the hot seat there, and they're all about personalizing the member experience. So usually all the things you see in the page, like which movies you get recommended and which rows kind of show up on the page, that's really their realm. And then we also have data scientists. And data scientists have like pretty diverse scientific backgrounds. Like if you look at their LinkedIn profiles, like some of them have a PhD in physics, some of them in like economics or cognitive neuroscience. So there's kind of
They're
a
mostly good at
variety,
math.
yeah, a variety of backgrounds. And they're expected to be like subject matter experts, domain experts, and they come in with, you know, whatever tools are going to get the job done. And usually that's either on Python or in R. And so they work on a whole bunch of problems that you don't end up seeing in the Netflix product. So things like, you know, helping, there's kind of this long-standing tradition in the entertainment industry of equipping like creative executives with data around like, hey, how well might this given show or movie do on the service? So like, you know, one of the areas is how can we improve on that with machine learning? There's also a number of fascinating problems in the studio space. So things like, you know, how do we scout out shooting locations and kind of like compare a cost curve? Or how do we optimize like the shooting schedule with all the talent that has to come together? All the way to like, you know, hey, once we've actually made the content, we're about to launch it, like is the localization quality, the quality of like the subtitles and the dubbing, is that great? And then once we get it launched, there's things like how do we make sure that you have the best quality video on your network, which varies across the globe with minimal interruptions. So all this to say, data scientists and algorithm engineers kind of have different types of problems, some of which are more visible than others, and they use different technologies.
Yeah, some of those sound like operations research kinds of things, like aligning, you know, all of the talent and where you're going to do it and when you're going to do it. Sounds like an
It's like
operations research
logistical,
problem.
yeah.
Mhm.
Like the stuff that
Traveling
FedEx
salesman
is
kind of
spent so much
thing.
time
Yeah.
on. Yeah.
Mhm.
Yeah, hopefully it's
It's
not
like
that
optimization.
and be complete.
Yeah. That's fun. It seems like there's a lot of fun problems to work on there. So
Mhm.
Yeah, and in my focus really has been on the platform that's supporting, and for the last several years, it's mostly focused on the data science side, and now I'm kind of widening my perspective to also the algorithm engineering side. Because we used to kind of think of these two as like, oh, there's two different worlds. We have the Java world and the Python world, and really as actually as neural networks become more popular, for example, like we need to actually think more broadly about bringing these tech stacks together and less in terms of like two different worlds.
interesting.
It's funny. It doesn't seem like the programming language should be that big of a. It shouldn't make a world. You know, it says how much that limits your thinking if they're
Yeah,
in two
and
different worlds.
well, maybe I should expand on those a bit because I think it goes beyond. It's not really about the programming language. I think it's really
Probably
around
the
the
ecosystem.
infrastructure, the
Yeah.
ecosystem, right? So if so in Netflix case, the actual applications, let's say behind the play button or that serve the page, are all in Java. And you know, you think about, well, what do you need to do to scale a system, right? You know, there's you know, for example, you know, even things like JVM performance, right, garbage collection,
JVM
tuning, those
tuning.
kind of things, all the way to like, oh, how do we build all the right like logging and monitoring and testing infrastructure? And so once you get beyond the language, now there's like all of these other pieces on top of that. And so there's a lot of leverage in reusing that. And then when it doesn't exist on the other side, you go, oh, wow, we're going to have to spend years, you know, really making this work, right?
Yeah.
And then not to mention, you think about an organization where, hey, we've hired a lot of people who are good, you know, working on the JVM, and you know, they have really deep expertise in like high scale operations, right? And so how would that look, you know, in Python? So I think it's more a question of like, when is it useful to use which technology? So one of the ways that we do think about it is because much of the data is coming from these live applications, like, what are you actually as a member doing on the Netflix page? What are you watching? Doing sort of all of the sort of feature engineering pipelines makes a lot of sense on the Java side, but then doing the training of the model, because that's where these modeling frameworks are, makes a lot of sense on the Python side.
Is there, and like with TensorFlow, can't you create the models with, say, Python, but then serve the model with Java or something? The models are somewhat portable with some of the technologies. Maybe not with PyTorch,
it's a little bit more duct tapey. I don't know if that's a technical term on the back end, because what you tend to do is you'll build a Docker image that runs the TensorFlow model, and then you end up calling that from your Java service.
Yeah.
So, yeah.
Interesting.
Yeah.
So the actual model goes into the Docker container, or is it stored in some file system?
Yeah. I mean, so, well, we have a little bit more sophisticated publishing mechanisms where there's this whole notification system, and yes, the model itself, in some cases, is actually published, let's say, to S3, and the Docker container picks it up. I actually don't intimately know the details, but I'm going to guess they probably don't bake it into the Docker image.
So you're saying, okay, so you write the model in Python and all the supporting things, and you stick that in Docker. And then how do you communicate with that Docker unit? Is that...
Well, and I'll say, like...
Okay, so it's like a microservice?
Yeah, so, and I'll say there's a couple different modes, because, in some cases, it's actually pretty expensive to what we call score the model live, which is you're actually not only sort of generating the features, but also calling the model. That can be expensive or cause too much latency in some cases. And instead of doing that, for some cases, we want to pre-compute a whole bunch of scores, like, oh, we have this many members, and we're going to generate your prediction all at once, and then it's ready for you right when you come. So that there's this sort of version of caching or bulk scoring that happens. We seem to have lost James.
I just sent him a text in case he hasn't noticed that he's dropped off. But yeah, well, technology.
Funny, I was worried my internet wasn't going to be good. I'll just do a quick sidebar, because maybe you have some good stories around this. I actually gave a talk to Yao Data in Australia Tuesday night. I was worried that my internet wasn't going to work well because I had been having problems. So I planned to go to the office. And then as I was leaving, I filled up my water bottle in the refrigerator. And then I heard this like whooshing sound, water coming out of somewhere. And I was like, well, that's weird. Maybe it's refilling, right? Go away. Come back a minute later, and there's an ominous puddle forming under my refrigerator. And at this point, it's about 10 minutes before I'm supposed to sign on to do my tech check. Anyway, so long story short, I had to pull out the refrigerator because I was trying to go outside to shut off the water. And, usually you open up the cement little things on the sidewalk to get to the water valve. All I found in there were cockroaches. So I'm like, okay, water's rushing out of my fridge. I have a talk in a few minutes. I can't turn the water off. So the best I could do was point the fridge out the garage, and the water was streaming down the driveway. The neighbor luckily was called in, and he figured out, because I have a landlady, and she called the neighbor. So we got the water shut off just in time. I got into my talk, and it was all good.
Wow.
And it was quite dramatic.
But yes, a little bit hair-raising. You were probably very energized by the time you gave your talk.
Right.
Full of adrenaline.
Anyway, for fun, do you have any, James or Bruce, any fun, like, last-minute talk drama stories?
Yeah. Probably the worst thing that happened oh, I'm sure there were worse things than this, but most memorable was this was years ago. I was doing a panel. I was moderating a panel, and I think this was at the software development conference that used to be a big deal. And I knew personally everybody on the panel, including the last person who I had co-authored a book with. But there's a thing that can happen where some part of your brain goes, not going to be helpful right now, like the part that remembers names. And so I'm going down, and it's like I'm totally aware that queue is empty. I do not know the name of my co-author right now. It's just gone. And I'm just
Your other thread took over all the resources, and
I think it's more insidious than that. There's some little kid in there going, no, not doing this anymore, or something like that. Anyway, so I get to the end and I just have to explain my way out of it, because the name was gone. And yeah, that was, I mean, I had experiences on stage. Oh, no. Oh, I see. I see what you're saying.
I think
okay.
Sometimes the squiggly lines don't work.
Okay.
Okay. Yeah, there it is. Okay. I had other experiences on stage, I think, by that time, where you go, oh, I might not remember my lines. And you just have to let it pass, because otherwise, if you start freaking out, if you attach to it, you're done. You just got to stay in the moment. I'm sure James has probably spoken more than I have, because it's kind of your job.
Yeah. Oh, so much stress involved in many presentations, and like moments before, like nothing's working, and yeah.
Oh, right, because you're always trying to do live demos.
Yeah.
That's like the worst.
Why do I do that? I punish myself.
It's effective when you see it. It's very effective. That's why you do it. But
it's more fun too.
Yeah, because
but things can go wrong, and
it's improv.
It is improv, and sometimes it does go wrong. Yeah, and there's a lot of stress in that.
Well, and I think you've done it enough and had it go wrong enough that you go, yeah, things go wrong, and you deal with it. It's not like, oh no, what if something goes wrong? Everything will crash and I'll be left alone.
Yeah. I've wanted to wear a heart rate monitor when I present, because I'm sure there are definitely moments where something's going wrong or whatever, where my heart rate just goes through the roof. It'd be funny to chart that. I should put it on screen live while I present, and then it would just be then everyone could see, like, ooh, things are getting serious. So
yeah.
I think you might get into some vicious feedback loops if you did that.
That's right. Yeah.
It's possible,
that's true.
But
the visualizing of my current heart rate could increase my heart rate.
Because you could just wear a smartwatch or something, and then I think you should totally do that. I love this idea.
Yeah. So luckily I haven't had to present on a stage for a while, and so we'll see the next time that happens. But
I like presenting on stages.
I do too. I'm so tired of virtual conferences.
Yeah,
They're
don't
exhausting.
get that whole immersion experience.
Yeah. So fun. Lots of fun stories and experiences there, but it's stressful. I'm glad I haven't had to have that stress for a while. Now I just have like a 3-year-old to give me replacement stress.
Oh, the joys of parenting. My son is 14 now, and this afternoon I'm taking him to get his first vaccine.
Oh, that's exciting. Yeah, because they approved it down to 12, so.
Yes. So
nice.
I'm very happy about that.
Awesome.
Bet.
Yeah.
I will bet.
Julie, did you know that Bruce and I are working on a book with Bill? You've probably met Bill.
Oh yeah, I know Bill.
Yeah. Yeah.
Yeah.
So we're working on a Scala 3 Zio book, and so that's been a lot of fun working on that. But Scala 3 was just released today. So,
You said that a couple of weeks
well,
ago.
it
What
was
that?
weird. Like a couple weeks ago, they were like, let's have a release party. And
Oh,
so we kind of celebrated the release of Scala 3 a couple weeks ago. But it turns out today is the actual day when the bits are available and live. So, but Zio has not yet been released for the Scala 3 release. So, but I'm sure that'll happen
Well, I'll
soon.
set my watch for 2026 when, let's say, Netflix folks get to use it. Because when you have infrastructure,
Spark is pretty
like,
laggy on update into new
yeah,
versions of Scala. So
pretty sure that there's still stuff in 2.11 and maybe 2.12 is what the state is.
yeah.
I thought it would be interesting, maybe because I kind of just went straight into some of the deeper side of the machine learning, but I thought it'd be interesting to like approach the question of infrastructure for data science from the perspective of a data scientist, because I think that might motivate like why it's so difficult. So let's give this a try.
Yeah.
I think I described data
I'm
science as
interested.
like having a pretty wide range of backgrounds. So imagine you're in a PhD program. You're working on some various projects, and I think the question is, well, what tools do you have at your disposal? You probably have a laptop. Maybe you have a machine under your desk, like maybe if you need to use GPUs. And you're probably going to be working pretty independently. And so, the first thing you might install is Jupyter Notebooks.
Yep.
You can like install Jupyter self-contained, on your laptop, on your desktop, maybe, on a cloud instance, but that might be pushing it. And then I guess the other question would be like, where would the data come from? Like you might.
Yeah, where do you get the data? Do you have access to it? Is it production data? Is it obfuscated in some way? Is it?
Yeah. And so like the easiest thing to do is look for existing, data sources. So like a lot of papers are written on these like very popular data sources. So like the most popular one is like called MNIST, which is a collection of handwritten digits that like Jan LeCun built this data set, I don't know, a long time ago. And so it's kind of like the standard for a lot of the computer vision type research. Or you might look at like Kaggle to find like a data set. And then if you have resources, you're probably going to try to partner with an organization. I mean, it could be, within the university, it could be trying to run a study, and you have to do a lot of work to collect that data. And you're probably going to end up putting it in some sort of data format on your machine, like maybe a CSV file or something, right? I mean, it could be as basic as that, right?
Yeah, you got to have it in some parsable form.
Right. And what your goal is I want to write the paper and I want to publish the paper, right? And so all you need to do is, really get things going in your Jupyter notebook, assuming the data isn't huge. And then you get your results and you write your paper, right? Maybe you have to, if you have large data, maybe you need to like get a student account on AWS and like run a cluster, right? But the short of it is nobody else probably has to make that machine learning model run, make that code run. And so then you graduate and you take a job at a company. And so the question is, okay, how do I do all this stuff at this company? Right? Well, the company probably has some kind of data warehouse, maybe a Hive store, for example. Again, if you're on the cloud, I'm most familiar with AWS. So maybe it's like sitting on S3 somewhere, and then you're not working on your laptop anymore. You're trying to work on like a cloud workstation. And like, how do I get the data? How do I get a cloud workstation? How do I get it set up with all of my dependencies? How do I get the data onto that workstation? And then when the data gets too big, like how would I sort of send that off to a cluster, right? And then once that happens, my colleague needs to get the same results, or we need to get this model into production. Like, it has to train, every day. And I have this whole pipeline that I wrote. I wrote a script, but like, how do I get it running, every day? So,
Yep.
I guess
All of a
when
sudden you have to learn Git.
right, you're right, exactly. So when you look from the perspective of a data scientist, like, you can start to see like so much infrastructure is needed, to get the job done. Like, once you land in a company, and this is not something that necessarily you're exposed to, at the university.
So I've seen some companies, the way that they deal with this is that they have the data scientists and they use Python and Jupyter notebooks, but then the way to get that code into a production pipeline and all that kind of stuff is that then an engineer takes the Python code, rewrites it into Scala, and then it works against the distributed like Spark system, whatever. And then that engineer knows how to do Git, knows how to deal with CI/CD, deal with like all the kind of engineering problems. So there are a number of companies that actually will just take the data scientist Python code and have an engineer rewrite it into the engineering system, which is certainly not ideal, but there are different concerns on each side. With production, there's concerns about performance and different things that the data scientist doesn't necessarily have to care about. So
yeah, but the potential benefits are so significant that having a whole person or people as a buffer makes sense, because if you can get those answers, that could make a huge difference in your company.
Yeah.
Well, I mean, let's expand on that setup a little bit, right? I mean, if you're talking about, let's say, a feature engineering pipeline that the data scientist wrote in Python, one of the primary concerns is going to be, is the data coming out the other end when you re-implement in Scala going to be the same as the data that came out in Python? And there's just all kinds of tricky issues that can come up when it comes to that re-implementation. How do you gain confidence that the resulting model is actually going to perform the same way that it did in a research setting? So
Right.
that's one of the challenges. And then another challenge is research is an ongoing endeavor. And so just because you had your version 1 that you had that engineer productionize, well, how do you get the version 2 out? And how do you actually compare whether the version 2 is performing,
A/B testing the
better
new,
than the version 1?
yeah.
So actually, this is the very problem that the team that I've been on at Netflix has been working on for the past several years. So there's all of these problems when it comes to sort of these lower layers of the stack, the data, the compute, the build, the dependencies. We built a system called Metaflow. When I say we, I mean the team. I hired them, they built it. A system called Metaflow. And Metaflow really tries to wrap all of these concerns so that the data scientists can interact, through a really simple Python interface. Basically, what you can do with Metaflow is create a directed acyclic graph in code. So you just write a Python class that has functions, and each function is considered a step in that DAG or a node in that DAG. And then you use decorators to kind of link those nodes together. And so what Metaflow does is it takes care of, how do I actually execute this thing? And then one of the main, benefits here is that Metaflow has sort of this built-in sort of DAG orchestrator that'll just run it on your machine like any old Python script. But then the beauty is you can also run a command line, a command that will take that DAG and really map it onto our production grade scheduler. And so as a data scientist, once you have your prototype going, you can actually say, no, I'm actually going to get it into production myself, and it's going to train, on this schedule, and it's going to produce either a newly trained model or new scores, on that schedule. And then for things like, we need to live score, like the pre-generated scores are not good enough. There's also a way that you can basically specify a scoring function that just simply calls the model. And then the what's called model hosting service will just wrap like a REST service around that for you. So as a data scientist, you don't have to learn, I don't know, how do I muck with like Nginx settings or like, set up
JSON serialization.
Yeah, exactly. So none of that has to be the issue. So for quite a few problems now with Metaflow, data scientists can really self-serve and like take the extra like re-implementation, the engineer out of the loop.
That's interesting, because you really did have to lay all of that groundwork in order for Metaflow to make sense to me. You had to say, oh, here's the problem we're trying to solve. And it's like, oh yeah, that is a problem. And then it's, oh, here's how we solved it. That's impressive. But somehow you were able to, I don't know, prove that this class representing a directed acyclic graph was 1-to-1 and onto, or something like that, that it covered the solution space.
Yeah, and I mean, most of these are pretty simple. So generally, it's a very linear graph, and then you might have like a parallel fan out. So like a really basic example would be something called like a hyperparameter grid search, where long story short, that when you're doing machine learning models, there's these things called hyperparameters that kind of that help control the architecture of the eventual model. So when we say neural networks, one of those hyperparameters is like, how many layers should we put in that neural network? And so there's no science that says, well, these are the hyperparameters you should have. You kind of have to discover which ones are going to work best. And so being able to actually train many very, very similar models in parallel is important. So you might, do a fan out to just parallel train a bunch of models and then sort of fan back in to go, hey, which model performed the best? So as an
example, you could have in your kind of deployment pipeline or whatever, you could say, all right, I'm going to train this model with 10 layers. I'm going to train this model with 100 layers, this model with 1,000 layers. And then I don't know how many layers are normal in a normal neural network, but so then you'll take those different models that are created and then test them in some way and determine like, okay, like the one that we trained at 10 was good enough, and so let's just go with that one, or whatever.
Yeah, or like learning rate is another type of hyperparameter. Like, how fast should we move along the gradient? Because if you move too fast, you might actually miss an optima. If you move too slowly, it'll take forever to converge. So there's all kinds of like.
And I vaguely remember at one point there was people working on using machine learning to provide the different hyperparameters, and so that it would be machine learning like deciding what the optimal machine learning parameters were.
That is definitely a thing. There's all kinds of like meta hacks to make machine learning better. I'll just tell you the one that I just learned about this week coming out of Uber. It's really fascinating. So one of the, there's those memes of like what my family thinks I do, like what
what my mom thinks I do, what my friends think I do.
So it's like what everybody else thinks I do is like this big white, blackboard with all this math, and it's very complicated. And like what I actually do is like import scikit-learn or whatever. So like, one of the problems or the quote unquote solutions, when it comes to building models now, especially with neural networks, is like let's just throw every single feature at this model that we possibly can. And like, you can get sort of very, very small improvements. At some point, there's diminishing returns, right? Problem is, that's expensive and it's slow at a certain point. And so Uber came up with this way to use information theory to figure out which features are going to be the most impactful on a model. So they look for not only a high degree of mutual information between the feature the feature and then the label or the truth, but they also want a low amount of mutual information between features themselves. Because if one feature predicts another feature, like the second one is not going to be useful. But if they don't predict each other, then they're more likely to inform the model. So there's all kinds of these meta tricks, built up around all these, around sort of the limitations, I would say, of
how
machine
we create
learning.
models. Yeah.
Yeah.
Interesting. That's wild. Just the whole space is so quickly evolved and is gaining so much maturity so quickly. And
so I have two questions. One is, okay, so Netflix knows when I pause and when I binge, and your machine learning models should be able to figure out the parts of a movie or a show or something where I get uncomfortable and I don't want to watch it for a while, or maybe I never come back to it.
or get bored.
So it seems to me that at some point in the future, you should be able to automatically generate the ideal script. So that's my first question. The second question is, will I ever be able to get a robotic vacuum cleaner that works?
I mean, on the first question, that's really not the goal at all. I would say, there's so much to the creative element when it comes to content that we're more focused on how do you sort of maximize the effectiveness and the creative excellence, right, of that creative process versus let's reduce it down to an algorithm. Because first of all, I don't think we can do it. And second of all, I just don't think that it would lead to amazing content. So that's definitely not a goal.
Wasn't there was some attempts at having AI write songs? Like songs are a bit easier to create. But I've never listened to one. I don't know if it's any good.
It was working from popular songs, so it was actually generating songs by taking pieces of popular songs and kind of remixing them, sort of.
Yeah.
And yeah, it actually came up with some good things, and I'm sure that'll get better because you write a catchy song and you can make a lot of money.
Yeah, I mean, I think especially with popular music, it's funny. My pandemic hobby is like picking the guitar back up again after 20 years.
Nice.
And just because I was much younger when I first learned, so I didn't make all these connections. But there's only a few chord progressions in popular music, and so it's probably much more plausible to write, songs that kind of sound good.
Or it could be a cobot kind of thing where you create a system that helps you write songs.
You could.
I could see that.
Yeah. Now, tell me, do you have a robot vacuum cleaner?
I got a robot vacuum several years ago, and it's like it didn't understand. Oh, I mean, power cords. It was going, nobody told me about power cords. I don't know what to do with this thing. Or if you had stairs that turned partway down, it would just find them and fall down them. You had to put up all these barriers, and it's easier just to vacuum your floor than it is to screw around with the robot vacuum.
Oh, I think this is bringing us full circle, Bruce, because think about, I actually don't know what's the technology inside of these, if there's machine learning or if it's like a heuristic model. But assuming there's machine learning, Well, they had to ship this robot vacuum cleaner with something in it, right? Some kind of model. And the question is, what were the conditions under which that model was trained? Did that include stairs with a turn in it? And could it figure out a policy for navigating that? And then I guess, are they a fancy company that would like pull all the data from your home? And would you want that, by the way? All of the different vacuum cleaning excursions. And then would you want it to train a new model and then upload that to your vacuum cleaner? So,
right. And maybe I just didn't let it fall down the stairs enough times.
That's right. It was not
my patience may not have
protective vacuum cleaner dad.
Yeah, it's kind of like, but then again, you have this kind of, if we're dealing with gravity here, we could damage the unit, so we need something more severe to keep that from happening.
Yeah.
But I think its algorithm was just, well, drive around, record where you are, and if you run into a problem, mark it on your map. But see, it couldn't understand power chords. So I think the instructions, when I actually looked at them, they said, well, you'll need to secure your power cords, and if you have freestanding rug, you have to do all these things to adapt to the needs of the vacuum cleaner. And that's not why I bought it. It was supposed to meet my needs.
Yeah.
So so it's in a drawer someplace, and I don't know what to do with it.
It keeps trying to get out too. It's weird.
This it's a problem that I have. I'm afraid to do experiments because I don't know what to do with the crap that's left behind when the experiment fails. I've got an e-bike, a vacuum cleaner, and then a bunch of other things that if I hadn't bought them already and I knew that they were going to fail, I wouldn't buy them. But now I've got these things.
Well, in Crested Butte, don't you just put them out on the curb and people take them?
You do. But my parents grew up in the Depression, and so it's like there's this little voice in the back of your head saying, "Oh, you could get money for that, or something," And so putting them out on the curb it's like, it takes some effort.
I wonder what would happen if we unleashed your vacuum just in town, just like let it just roam around and try to clean all of town.
Have dog poop smeared all over the place.
Yeah, it reminds me of that story about the person who woke up to their house just covered in dog poop,
from
the robot.
Right. Yeah, see that? Yeah, that's the kind of thing. They're so dumb and so underpowered too. So we need batteries that allow us to have bigger, smart vacuum cleaners, more powerful ones, and then it's like we'll get that.
What's interesting is the vacuum cleaners are pretty dumb, and who knows if they actually have machine learning or not. But I was thinking about how much of the technology that we touch every day now is backed by AI versus 5 or 10 years ago, and it's changed pretty dramatically.
Yes,
but I think it's probably changed more dramatically on where we touch tech companies versus where we touch, because Netflix can afford really high salaried data scientists, machine learning experts, all that. Whereas Roomba, maybe they're not willing to pay 100 engineers $1 million a year or whatever it is to actually do this stuff right.
Yeah. So they can say, well, it's sort of like artificial intelligence, so let's say that it is.
That's right.
It's kind of my experience.
So I'll give you another, when you talk about proliferation, another wild example. So I went over to Santana Row in San Jose a couple nights ago, and they have installed these, sort of signs that say how many parking spots are left. And now every row will have green or red lights depending on if there are parking spots available.
Nice.
And there are cameras. And I guess naively I thought about, well, could you implement it by sort of having, a classifier that just looks at, is there a car in that space or not? That was kind of my naive idea about how it works. And then I get down to the first floor of the garage and I notice this little sign, and it explains what's happening. They take a picture of your license plate. And so they are actually tracking license plates in the garage, and then they're explaining, well, who has access to this data? People at the company, and here's all the training that they have to handle this data.
So they don't actually look at the car spots. What they do is they just track, okay, this car came in, this car came out. And so that's just as identification of in and out versus there's this spot is actually occupied.
There's possible scary implications to that. But supposedly it's only being used for this purpose of parking. Only
for good.
But I mean, there's no clear warning, going in, your license plate is going to be red if you come into this garage.
Yeah.
So if you're in a high-speed chase and you duck into a garage to try and escape the pursuers, they may be able
to find
discover you.
Well, and based on all the traffic cameras that now record your license plate.
So this I'm sure this, not to go down a dark hole, but I'm sure you could subpoena such information if you need to be.
Yeah. But if it was on the blockchain, then everything would be okay. It would all be better. That's what I've heard.
Solves everything.
That is my understanding.
Even naming and caching problems are solved by the blockchain.
That's right. Exactly.
Yeah, I don't know how it works, but I do know it's the solution to everything.
Yep. I actually saw somebody say basically that recently. And of course, they were a blockchain company.
They said they didn't know how it worked?
No. They said the prior thing, which is, yes, put everything on the blockchain. All of your data privacy issues will go away.
No. All of your money issues will also go away.
Right.
Buy some Dogecoin today.
Mm-hmm. Yep. Yay, capitalism.
That's fun. Wow. I've been educated, as always, with Julie on many different things. I'm trying to think if there's any other questions I have, since we have Julie on, and she's such an expert in kind of everything.
Well, can you talk more about your book? Maybe you've talked about it on previous episodes.
Just on the last one is where we went into a lot of depth on it. We're kind of calling it prep, which is still just a joke, but
I think people like that.
The prep methodology.
I'm gonna say that should be on the cover somewhere, but I don't know that would be the actual title.
Right. Yes.
Yeah.
Which stands for performant, reliable, expressive, and productive.
James is very pleased with himself that he came up with this acronym.
Yeah.
Whether it actually applies to the book or not is going to be a whole other question, but that's kind of what we're going for.
Yeah.
We're going to solve all of the current software engineering problems with this book, so that we can then move on to the next level of software engineering problems.
Which sounds like it's going to be machine learning.
Yeah.
Yeah.
It's like the new reactive. Maybe a closing thought is, I don't think you can build awesome platforms if you don't think about people, in particular the people that are using the platform, and what's their whole experience. And the way you describe prep sounds like implicitly you're thinking about what are the entirety of the concerns that a software developer needs to think about.
Yeah, and people are the hard part.
Kind of. And what are the problems that we're really encountering? I mean, the problem is that a lot of these issues, people go, oh, well, parallelism is hard, and that's the end of it. It's like, it has all these problems, and that's where we stop, rather than saying, oh, how would we solve that? And that's what, we're not solving the problems. We're just trying to explain how the problems are solved using these improved technologies. So it's, we're trying to deal with the actual problems that people encounter rather than just the usual approach to concurrency is just to say, oh, well, you start these processes and then somehow you have to stop them. And that's part of the art or any number of different issues, like, well, they're inherent problems that can't be solved by themselves. And what this other system does is it says, no, we should actually change things to solve that problem because individual programmers can't. It's just with the systems that you have now, they can't.
It's like saying, I'm driving down the hill and my brakes are out, and that's a problem, and we'll stop talking about it right now.
Kind of. Yeah, pretty much. It's like, well, you just have to steer carefully so you don't run into anything when your brakes are out. I'd say that's a really good analogy.
Yeah. So maybe at the STFU conference, the STFU unconference, or no, that's repetitive. Anyways, at STFU, we will have a prep workshop or something. Try out some of the content.
That sounds like a really good idea.
That'd be fun.
Mm-hmm. Yeah.
So hopefully Julie can come to that.
Mm-hmm.
That's in August, right?
It is. It is August
Julie had asked about the
15th through the 21st. That includes your arrival and departure days.
Sounds awesome.
Mm-hmm.
Well, hopefully we see you at that. And it's been too long since we have seen you, but it's good to see you virtually and learn from you as always.
Yes.
Well, this was delightful.
Yes, it was very nice.
All right. Well, thanks, Julie.